Today's video, it's all about blowers, fans, or whatever you like to call them. They provide the combustion air to make the burner work so you can melt the metal in your backyard furnace. Here is the first example. It's what they call a squirrel cage fan blower. Very easy to get hold of. This one came from a microwave oven. Here is a much larger version of the microwave oven cooling fan. It's exactly the same fan. It's much larger. It's a squirrel cage fan blower. And this one here will be conducting quite a few experiments and put it onto my furnace, and we'll see how well this blower works. Now for the first experiment, I've hooked up an amp meter and I'll switch on the motor and we'll see how much amps it draws. About 0.77 of an amp at full airflow. Now we'll block it off. And we've got 0.43 amps. I've connected an adapter so that outlet hose will fit onto my burner on my furnace to make it work. And we'll just have a look and see what the amps draw is now that I've put some sort of a restriction on the outlet. As you can see, the amp reading was not much further or above what it was when the inlet was fully restricted. This means that this blower, which is a low pressure blower, if there's any kind of restriction like this adapter, they will not push a lot of air into your furnace. This time round I will block off the inlet and recreate the same amp reading. As you can see, it's very restricted. There's not much air coming out the outlet. So if you do use one of these blowers, you need to have ducting that diameter and that size to fit straight into the furnace and no restrictions. The blower has been connected to the furnace. There's the connection. There's the furnace. Here is the next blower I'm going to try for my furnace. It's called a side channel blower. It's probably the best blower you can ever get, but it's also the most expensive to buy new and very hard to get second hand. There's the motor that's driving it. There's my motor generator set up. This side channel blower has a very unique sound when it starts up. It sounds exactly like a jet engine. Also, this one needs to be soft started. I'm going to use a slipping belt to do that because the propeller is such a large diameter. It takes a while to accelerate to maximum speed. I'll explain one more fact with the side channel blower. It is what I call a positive displacement blower. So if you block the inlet or the outlet, the amps rise. It compresses the air. All other blowers, the amps drop. With that in mind, you have to use a T-fitting if you want to control the air coming out. Like so. Later on in the video, I will explain a little bit more about that T-fitting and using as a diverter and controlling the air in another blower. Here is a close-up of the side channel blower. You can read the label. If you want to get one yourself, they should be online. I see it's made in Benton Harbor, Michigan, USA. This next blower is the blower from my cupola. It's a very good blower. Puts out heaps of air, more than I could ever use. We'll do a quick walk around. This blower has a very large output, and the reason for that is, have a look at the motor. It's got a very large pulley, and then you look at the blower, it's got a very small pulley. The motor runs at 2,800 RPM, so the final speed for the blower is about 11,500 RPM. And to control the air for this blower, we use a flap across the inlet like that. Now, before I switch the blower on, have a look at the adapter I've made up. There's the threaded portion that screws into the outlet, and there is the step down adapter so I can use a vacuum cleaner hose so it runs into my furnace blower. But watch carefully, when I unscrew this adapter, the amp meter will be on the top right hand side of your screen, and you'll see how suddenly it will rocket up in amps, and that means it's putting out so much more air. Any kind of adapter or step down adapter will cut down the amount of air you can use from your blower. Now, comparing this blower to the very first blower I showed you on the video, this one runs at a faster speed and therefore produces a lot more pressure. But even though it produces so much more pressure, putting restriction on the line and running it through that corrugated vacuum cleaner hose to the burner, you can see by what was on the amp meter, it produces so much less air. But it still is a very good blower. Here is a close-up of the ID label on the blower, just in case you want to buy one exactly the same. Here is the vacuum cleaner. It's used as a blower in my furnace. This is one I built for someone else. It has got that air diverter I'm talking about just here. This is the air diverter I'm talking about. I've used an old gate valve, and the air comes out of the vacuum cleaner here and it comes straight out there. Now, to make it work, you ease off this gate and the air starts to divert around there into your furnace. When you shut that completely, you've got full airflow into your furnace. Now, the reason why you've got to use this air diverter is because the air comes in through here and out here, and all this air that comes through here cools the motor. If you restrict it in any way, the motor will overheat and burn out. So that's why it's got the diverting arrangement on here. All the air comes through here. The other way to control these motors is to use electronic speed controller on them. That works just as good, but a lot of people don't like electronics. This is a very simple solution to fix the problem, to control the airflow to a furnace. Here you can see when you restrict the air, the amps drop